involving 2 carts weighing 300 pounds, racing on a quarter-mile track. Cart 1 has a best time of 40 seconds, and cart 2 has a best time of 43 seconds. What we need to know is, what is the velocity for both carts? What is the acceleration for both carts during a straight stretch of 30 feet? And what is the force exerted by both carts?
The mass is 300 pounds. Converting it into kilograms, which is 136.077. We have our time for cart 1 is 40 seconds. Time for cart 2 is 43 seconds. And then the distance of the track is a quarter mile. And then converting it into meters is 402.25. 25. So, what's the velocity of both carts? We're gonna find the velocity of cart 1. X minus initial x over time. Can you see this? Equals 402.25 over 40 gives us 10.05 for the velocity for cart 1. Velocity for cart 2, same equation. And then we're going to take the time of the second cart, which would be over 43, equals 9.35 meters per second. And that'll be the velocity for cart 2.
We're going to find the acceleration for a given distance. So we know that the velocity of cart 1 was 10 meters per second. So if we plug that into this equation, so we have v squared equals v naught squared plus 2a delta x. And we're going to solve it for a, so it's going to turn into, since there's no initial velocity, v squared over 2 delta x. So then we're going to plug that in your toy, and you're going to come up with 5.5 meters per second squared. And then really quick, just so you know what it is. So the v squared is going to be 10 squared over 2, and the delta x is going to be the change in the distance, which is going to be 30 feet, which is going to convert to 9.14 meters. And then you're going to get that for cart 1. And then the velocity for cart 2 was 9.35 meters per second. We're going to do the same exact equation, so we're going to have the A equals v squared over 2 delta x. So we're going to do the 9.35 squared over 2 times 9.14. And again, the 9.14 is going to be the it's going to be
the 30 feet that we're converting into meters. To find the acceleration for the given distance. And when you plug this in your toy, you're going to come up with 4.8 meters per second squared. So now that we know the acceleration for a given distance of the 30 feet, which is going to be 9.14 meters, now we're going to find the force of both carts. So force of cart 1 is going to equal MA. We know the mass of the carts is 300 pounds, which converts to 136 kilograms. And we're going to times that by the first acceleration that we just found, which is 5.5 meters per second squared. And when you plug that in your toy, you're going to come up with 748 newtons for the first force. For the second force, we're going to use the same exact equation, so that mass times acceleration, and the mass of the carts is the same, so it's 136 kilograms times our other acceleration, which is 4.8 meters per second squared. Plug that in your toy, and you're going to come up with 653